All right, welcome to today's session about open source-based congestion management. We are a team of Artelys and Accenture. From Artelys, there's Gladys and also Nicolas Omont, based in France and Spain. And from Accenture side, there's Jordanno Paiva, based here in Germany, and myself, Jannis Kahlen. I'm located in the Netherlands. So, today, we would like to give you an overview about congestion management in general, an overview of tools that you can use for congestion management. We will give practical examples, conclude with a summary, and then we'll also have some time for Q&A. But let's start with the introduction. So, if we take a look at the electrical grid today, we see that there's more and more renewables in the grid. We see that there is more electrification of transport and heating. We see that there are more and more decentralized energy resources. And all these things pose challenges to grid operators. Why? Well, because there are more and more bottlenecks in the grid, because the capacity is not enough. We see that the load flows are becoming more volatile. And also the events that happen need quick responses from the grid operators. Well, you could now just build more assets in the grid to solve these challenges. Just build the copper plate. But let's face it, we won't be quick enough with that. So what do we need? Well, we need congestion management. And guess what? That's the topic of today's session. So let's start with what is congestion management. Congestion management, there are different strategies to that. You can do redispatch, so changing generation schedules of power plants. You can do curtailment, limiting renewable generation. But you can also do demand response, topology switching, and so on. There are many more things that you can do, but these are, well, strategies that you can utilize. And we actually see that these things are being utilized in Europe. If we take a look at the grid operators in Europe, they are using that. Here on the right-hand side, there's an example of Germany. We see the evolution of the volume on the top and the costs here on the bottom part of remedial actions in Germany. And what we see is that there was an increase here on the top part, where you see the on the y-axis the volume, that there was an increase of 45%. 45% increase of the volume in just 4 years. And that translates also to costs, because all these remedial actions, they come with a cost. And alone in 2023, alone in Germany, that was 2.5 billion euros. And this underlines the need to automate and also to optimize congestion management. And maybe just a quick question here. Raise your hand. Who is working on congestion management solutions? Well, a couple of people. Or who has planned to develop congestion management solutions? Well, also a couple of people. That's nice, because that's relevant. And so let's also take a look now into how we can achieve that. How can we optimize and how can we automate congestion management? So let's first start with, okay, well, what's required when we want to build that? There are a couple of modules that you definitely need. Of course, there are more modules, but let's stick here to the basics. The first module that you need is you need some kind of data management, some kind of data orchestration to collect data, summarize data, with the purpose to then be able to have a consistent data flow across all the other modules. Because you are going to use data. For example, in the second module, because in the second module, you're using data to forecast congestion, to forecast consumption and generation. Because only when you do forecasts, you can plan ahead. And this is what you need for congestion management, planning ahead. That data can then be fed into the third module, grid simulation and analysis, because what you can do there is you simulate load flows. You can evaluate the grid, and you do that to pinpoint where in the grid there is congestion and at what time frame. Because that's what you're going to use here in the fourth module. In the fourth module, you are then evaluating how can I mitigate that congestion. Because maybe you have different options available how to mitigate that. I already named a few earlier, like curtailment, redispatch, but there's maybe also flex contracts or whatsoever. And the idea is, okay, well, how can I maybe combine certain options, or how can I identify which option is the best option to solve that specific congestion? This is what the fourth module is all about, to find the optimal solution for the problem. And optimal can here be many domains, can be reliability, but also costs and so on. And then, well, if you have identified what is the optimal solution, of course, you also want to activate it in the fifth module, in real time. So, okay, well, these are the 5 basic modules that you need, but how can we build that? And for that, well, we propose open source tools. Why open source? I think everyone here should be aware, well, modularity, avoiding vendor lock-in, transparency, and many, many more things. But also the nice thing is that with open source tools, they can either replace commercial solutions, but they can also coexist with commercial solutions. And this is where we think this is really important. And we will also touch on this in the practical examples later, what that means and how that could look like. So everyone here should ask him or herself the question, if you are developing congestion management solutions, well, is it a make decision? Is it a buy decision? Or should we also aim for the third part or third path? Collaborate. And now I would like to hand over to my colleague Jordanno to give you an introduction into the tools, the open source tools that can be utilized to fill all these 5 modules with life.
Thank you, Jannis. So we would like to start showing what tools are available from LF Energy that could fit in those functionalities that Jannis just presented, but also more tools that maybe are not from LF Energy. As you can see here, first thing to say about this list is this is very far from an exhaustive list. So if you look at the data handling, there's a whole universe there. Another point, the impact of some of those tools is much bigger than what you actually see. So for example, when you have Panda Power working under the hood of many commercial solutions, I think if there are German DSOs here, many of the commercial providers of 14A solutions are using actually Panda Power, for example. Or if you're using Azure Databricks, you're actually using Spark under the hook, or Google Orchestrator, or Airflow, and so on and so on. A third point is those tools are not interchangeable one-to-one, so they are mostly fulfilling different roles. So if you look at the data handling, you could use Grid Exchange GXF to collect data from smart meter, and then use RTDIP to make this data available, or you could use Spark to make some transformation in this data, and you could use Airflow to make this data work across multiple processes and multiple tools. The same thing you can also say about the other tools. They each have their own strength, maybe on the context that they were created, or their capabilities are focused. For example, PyPSA is much stronger on planning, while Possible and Power Grid model much more on real-time modeling, or And some of them have some functionalities that others don't, and depending on the usage you're having, you will prefer one or the other. Another thing that you can see is that sometimes the same tool can also bring other functionalities. So for example, Possible and Panda Power also have native optimization capabilities. So with open source, we want to show that not only you have a lot of options, but that you can also arrange those options in different ways. So you can actually find the most suitable solution for a wide range of problems. And with this, the main challenge is to actually choose the solutions and integrate those solutions into your process. And for this, we would focus yet now more on the forecasting, grid simulation, analysis, and optimization part, as the activation and data handling. The data handling will almost always be defined by your wider IT landscape, while the activation much more by the options that you have, sometimes also by regulatory restrictions or market design. With this, we want to show how to actually go ahead. Okay, I have this problem, and now I need to make out of those many tools a solution. I think when we are working with open source tools, it's much more important to define and to understand your own problem, because you have all this freedom. You need to evaluate and compare the many options. And then this is a very important aspect of open source, to actually engage with the community. Maybe as important to know the functionalities that are available now is to know what is the roadmap, and if the community that is involved also shares the same challenges and the same views as you, because then you know that this tool will keep being relevant for you also in the future. And then you go to the part of actually doing it and integrating it into your process and building it. And for this, I would like to give the word to Gladys, where she will present some concrete examples on how those shoes can work together.
Thank you. Okay, so we'll present some practical examples that are based in our experiences or projects that we have done on the context of congestion management or other similar contexts. So the idea is that we can, the workflow we can separate in two big steps. Now, in the first step one, you need to prepare the grid digitalization, right? So how do you deal, or what the approach for this step will depend mainly on what is the maturity level on the tools you already have, what system you have already to view or have a consistent view of your grid, because that would allow you to make good forecasts. Of course, that's the base for having good forecasts, and that detects congestions. And for the step two, which is where you assess the congestions and you propose solutions. And then you have to search for the optimal solutions depending on several criteria. So, and as Jordanno said, on the last part, so this will be your inputs for activations of resolutions of resolution proposal. So if we go to step one, The different tools of processes that we're showing here are common to many tools or solutions for power systems, right? So it's not only, you may agree on that, for congestion management. So in order to have a good view, a consistent view of your grid, you need, of course, to make sure that your data is good quality, not only from the data point of view per se, but also from the power system perspective, right? So you'll see possible a lot on these blocks, and that's a good reason why, because Artelys has been involved for a long time now in Possible, and we have done a lot of projects. We are part of the community, so the examples that we will explain here, of course, comes from our experience working with Possible framework. And then the idea is that, as I said, first make sure that from a power system perspective, your data, it's complete and it's good quality. And this allows you to then run simulations, run load flow, and make sure, for example, that you can validate the grids models that you're using. And here, there is another example that Nicolas will present in the next presentation, which is, for example, the merging of models, right? So, that project, I mean, the experience so far is merging of TSO models, but in congestion management context, merging of TSO and DSO model will be for sure a point that we need to tackle in the near future. Then also, of course, we have used Possible many projects for simulation, grid analysis simulations as the main flow computation models, open load flow. And then also for state estimation has been also used Possible. And of course, having the more precise you can be on the state of your grid, that would allow you to use to have more precise forecasts and detect congestions. And here in this chain, we also present OpenStep, which is widely used by operators to have forecasts, calculate forecasts. And in particular, we have one of the tools used in the example that which I show you in a second. So on the step 2, I would say that we have projects that we have done that are really on the congestion management context. So what we first show on the strategy optimization is you need to be able to select what is the optimal solutions. One, you detect the congestion, and for this you need optimization for sure engines that allows you to, given your criteria, economics, products availability, and the different flexibility strategy that you can use to solve the congestions. And here, for example, we mentioned different, not only open source tools like Pyomo and Hives, but we also show non-open source commercial tools like Ample and Nitro, which is an optimization solver developed by Artelys. So, and it's true that in this type of problem, these are non-linear problems that need to be solved. And there is another complexity, an added complexity when you do congestion management, is that your inputs are probabilistic data that come from forecasts. So you have certain probability. You have to see how you use this input in your optimization problem. So we have done a project in collaboration with Accenture using fully open source tools. But of course, there are limitations, and in our case, we have done also projects using Nitro. Since we developed the solvers, we have much more capabilities on the sense to treat very complex nonlinear problems. And there is another step what we haven't really attacked on the congestion management, which is security analysis, but of course, Possible security analysis model, we have used it in many, many projects. So idea is when you choose your optimal strategy, you need to be sure that it's secure, right? So you have to run security analysis and in order to really have the final strategy that you will activate. So that's the examples that we wanted to show, which are really a mix of different projects that attacked the different pieces on this congestion management process. So, oops, sorry. Why it jumps? Okay. So as we saw, we have congestion management is a real problem that needs to be tackled. There is an important point on what we have said, different important points that we have seen. And I think that it's relevant to know that it really depends on the maturity level of the client. It means a TSO and DSO have completely different levels of maturity. For example, on the grid digitalization side, and that would, of course, be a really important point on the choice of the tools you want to implement and you need to implement and integrate. Then, of course, you have a whole community to collaborate between to try to lower cost and speed up development. You have the customization, which is one of the, I would say, one of the really challenging part is that you have different congestion management approaches. You have to see what are the tools that are best fits your given, let's say, objective, and how you mix this open source tools and commercial tools in the right way in order to solve the problems. Open source, as we said, we have many tools available already that can respond to these questions, and well, then that's it. I don't know if you have any questions. Yeah, we have one there. There's another mic. Okay.
Wait, maybe. Just. Can you activate this microphone? Hello? Ah, there. Who had the question? You. Sorry.
Thank you very much. I think it was an excellent presentation. Well done. My question is, when you have several modules in a TSO server room or control room, do you put them in different servers, or do you have all these modules in one system? The second question is, do you have to acquire all, or do you have harmonized modules? Yeah, so, well, maybe I can respond, and then I can let also Jordanno complement. The idea is that there is not a single solution, right? So what we are proposing here is that you need to you have a lot of tools available already, open source tool that you can mix them, but of course they are not plug and play, right? So you need to see how you harmonize this tool. You need also people with capacity to understand how this tool works and how to make them to work together. So that's the on the customizations part. That is one of the challenges or you have to adapt what is existing to your process, to your specific process. That's I don't know if you want to comment on that. No, Jordanno.
No, exactly like Gladys said. I think also another important point is that maybe the same tool will be used repeatedly for different roles, also as was shown. So it will very much depend on the problem you're trying to solve and then the capabilities that you have. Like, for example, Gladys showed that you could also use power flow simulation for an improved data quality control. Maybe this is needed for DSO mostly, but not at the TSO. On the other hand, if the TSO needs to do some merging of models, again, it gets more relevant. So the answer will depend on the specific situation.
I have a question regarding the actual use case or how to import the data, because we know Possible mainly has a CGMES interface. How do you deal with getting actual data into Possible? And what do you do if you need multiple grid operators' data as one? Because we also know often in congestion management we need multiple grid operators' data. Yeah, is there any example that you can name, or how do you deal with that?
Yeah. Okay. So I think in Possible we already, it's not only CGMS, but you can also import the other data, UCT, PSSC. I don't know, Nicolas knows the list of all formats, but there are several formats already that you can already import and Possible solutions. So, and that's the idea, not only standards one, of course standards are mandatory, so they are there, but you can also import some of the formats. And of course, if for specific projects we need to develop for import for a certain format, then that's a development that needs to be done, and it's done. Yeah, for sure. Yeah.
Also, one advantage is that if you need a converter that is not there, you can also extend the functionality because it's an open source tool, and develop it. So it also could be an option, even though, as Gladys said, Possible already offers a lot of options. Yeah.
Any more questions?
I think we're also out of time.
All right, then thank you very much. And if you have any questions, just feel free to just approach us, talk to us. We're happy to discuss this topic with you because we believe that congestion management is super relevant for every grid operator in Europe, also across, well, not only in Europe, but also in other countries. So feel free to reach out to us and discuss this topic with us. Thanks.